Today we're going to learn how to graph functions using a neat program called Symbolab, and we will understand and learn some of the important graphs that we need to be familiar with in order to do well in calculus. So I'm going to start by going to Google and searching for Symbolab graphing. So let's go to the Symbolab graphing calculator. Okay. So right in this little box, let's type x squared. Okay, so that's the most basic graph. Y equals x squared. And notice it's just a parabola. Now, if you change the x to something like x minus 4x squared, you can see that it shifts the parabola over to the right by 4. And of course, if you put an x plus 4, it would shift the graph to the left by 4. If we put the 4 on the outside of the square, so something like x squared plus 4, then we shift the graph up by 4. And if we subtract 4, we shift the graph down by 4. Alright, so that's our favorite calculus function, x squared. Of course, if the leading power is positive, the parabola will be face up. And if you put a negative number in front of the leading power, it'll be face down. Okay, I guess even before we study parabolas, we should make sure we understand lines. So mx plus b. So in this example, 4 is the slope and 7 is the y-intercept. That's a positive slope function. A negative slope function would go down from left to right. Sometimes the slopes are fractions. So this means we go over to the right 3 boxes, and then we go up 1. So that slope is still positive, but it's smaller than than if the slope was 1. So if the slope is 1, then you go over 1 to the right, you go up 1. Okay. So next, we have x to the third power. Notice that it looks like x squared, except it reflects over the origin. This is an odd function. X to the fifth power basically looks the same. It'll be a little steeper, but it's basically the same graph. In fact, any odd power will look the same. And notice that to the right it goes up to infinity, to the left it goes down to minus infinity. Now, if we have an even power here, x to the fourth, well, it pretty much looks like x squared, except it's flatter at the bottom and it's steeper as you move away from x equals 1. So once you pass x equals 1, the graph starts to get starts to get steeper. All right, and as I said, any even power will basically give you the same graph. All right, so far we have the really two graphs. We have, well, we have the line, so maybe three graphs. The lines, we have the parabola, an even power, and we have the odd powers. Okay, next we have the square root. So the square root of x looks something like this. As you can see, it still goes to infinity to the right, but much slower than x squared does. Notice you can only plug in non-negative values of x, so there isn't any negative values here. So this is the same thing as x to the 1/2 power, right? That's the same thing as the square root of x. So if we want to get the cube root, you could either use that symbol up there, or better for calculus, just say x to the 1/3 power. Notice it looks pretty much like the square root, except that it continues sort of like x cubed did. And if we go to x to the 1/4 power, it looks just like the square root function. All right, next, 1 over x. So 1 over x is, of course, the same thing as x to the -1 power. So odd powers are odd functions. X to the -2 power is the same as 1 over x squared. Notice as x approaches 0, the graph goes to infinity, and as x goes to infinity, 1 over x squared goes to 0. Horizontal asymptote, y equals 0. Vertical asymptote, x equals 0. Okay. 1 over x to the 3rd power looks exactly like 1 over x. 1 over x to the 4th power looks exactly like 1 over x squared. Okay. Now, you can shift the graph of 1 over x to the right by 4, like we did before. We can shift it to the left by changing the x to x plus 4. Now we have the vertical asymptote at x equals -4. All right, so far we've looked at the algebraic functions. Now, things get a lot more complicated when you have, stuff like x over x plus 4. Then it's not so easy to graph it. So you're not expected to memorize things like this. But just to show you what's coming, see, let's say you have x to the 4th power, and then a bunch of other powers, like 3x cubed minus 2x squared plus 1. Now, if you notice what's happening here, I think you could see it a little better maybe right here. When x is big, it's basically the graph of x to the 4th. But this extra term sort of perturbs the x to the fourth graph a little bit. See, look, here's x to the fourth. It's a nice parabola type function. Then you start adding things, and you change the shape of it when x is near 0, but in the long run it still looks the same. See, if we put an x cubed here, so we've changed the shape in the region near 0, but when x is big, it pretty much just looks like x to the fourth. Okay. All right, now we need to memorize the exponentials and the trigonometric functions. So the most famous exponential is e to the x. Notice you have it goes to 0 as x goes to minus infinity, and it goes to infinity very quickly as x goes to infinity. In fact, if you graph this with like x to the fifth power, then it looks like, see, this purple graph is x to the fifth, but it looks like the purple graph is sort of going up faster, right? But if you look at it in the long run, well, it's hard to get a good picture. So here's how we can compare them. So you could have x to the fifth divided by we do a fraction. So x to the fifth divided by e to the x. Let me go back to where I was before. Let me just refresh this page. It looks like I messed up the scale. All right, so this is just a little bit of extra. X to the fifth, how to compare two functions, e to the x. So we're going to learn a lot about this later on in calculus, but as you can see, x to the fifth is about 20 times bigger than e to the x over here. But then look what happens. The e to the x takes over and brings it down to 0. So e to the x is growing a lot faster than x to the fifth. Another way to see this is e to the x minus x to the fifth. So it's negative but eventually e to the x is supposed to take over. Doesn't seem to be working out on this program. I'm not sure why, what's going on. Maybe the scale was messed up with it. So forget about that. That didn't work out. All right, so we have the graph of e to the x. Now, you should definitely know that, e to the minus x. It's just the same thing as e to the x, but reflected over the y-axis. If you put a number in front, then what you do is you do a vertical stretch. So here's 4e to the x. So this point here is the point, the y-intercept, 0, 4. And in fact, you can even put a number in front of that x. It just makes it a little steeper. It just makes the graph a little steeper, that's all. But it's still the same graph, e to the x. Alright, so we have the graph of e to the x, and I showed you e to the minus x. Any other base gives you the same exact picture. 2 to the x, 3 to the x. However, when your base is less than 1, you get the exponential decay. And the reason for that is that's exactly the same thing as 2 raised to the minus x. Okay. Next up, logarithms. So the natural log of x. Notice only allowed to plug in values greater than 0. And if you try to get too close to 0, the graph will head to minus infinity. So the limit as x approaches 0 from the left, minus infinity. Sorry, I said it wrong. As x approaches 0 from the right is minus infinity. All right, so here's the natural log graph. As you approach 0 from the right-hand side, the graph goes down to minus infinity. All right, so that's the natural log. All of the logs will look the same. I don't know if I can graph the other logs of this program, but let's see. Yeah, so here's log base 2. You almost never see that graph in calculus, but the graph is the same as the natural log. All right, so notice the natural log does go to infinity, but very, very slowly. But it still does go to infinity. On the right, minus infinity as you get near 0. All right, next up, trig functions. Sine of x. Make sure you memorize the sine of x. Its period is 2 pi, which means it repeats itself when you get to 2 pi. So here's 0. This is 2 pi over here. Maximum is 1, minus 1. It achieves the maximum at pi over 2, and the minimum 3 pi over 2, negative 1. So maximum value is 1. All right, that's the sine. Cosine of x is a shift to the left of the if you take the sine and you pull it to the left by pi over 2, you will get the cosine. So cosine starts at 0, 1, and then just does the same thing the sine does. Period is 2 pi. This is pi minus 1 is the minimum, and 0, 1 is the maximum. All right, you should definitely know how to draw cosine and sine. Tangent of x. Vertical asymptote at pi over 2 minus pi over 2. Goes up to infinity here, down to minus infinity. The other graphs like cotangent, cosecant, you don't really need to know those. I mean, I'll graph them for you quickly. There's the cotangent. Cosecant of x. And the secant of x. As I said, you don't really need to memorize those graphs. Just sine, cosine, and tangent. Okay, what you should know is the arctangent, though. We see that a lot. So arctangent of x has a horizontal asymptote at pi over 2 and minus pi over 2. So it's a nice graph, but it never gets higher than pi over 2. It never gets lower than minus pi over 2. All right, and then once we have our graphs, later on in calculus, we're going to learn how to, how to find the graph of more complicated functions. But right now, you don't need to do this, of course. But graphs can become much more complicated. In fact, here's 1 over x times the sine of x. This is an oscillating sine curve. All right, so while I'm here, let me show you a little bit about the Symbolab. What you can do with Symbolab. You could do limits. For x squared minus x over 2x squared plus 1. And the answer is 2. It even gives you the steps sometimes. Sometimes it wants you to pay an extra amount of money so that you could see all the steps. But it often gives you something. Let's try something different. Sine of x. So it diverges. Diverges is the same thing as does not exist. Try something we've been doing in calculus already. Limit as x approaches, say h approaches zero. I think the way you write it is x2. So limit h to 0. So fraction 4 minus 1 plus h quantity squared minus 1 over minus 1 divided by h. This is something we were working on like today in today's class. All right, and it looks like it can do it. The answer is 2. And if we look at the steps, when you simplify this, you get h plus 2. Then you let h go to 0, and you get 2. They even do a graph of this. When h is 0, notice there really is an open dot right here. So this is a great program, and you could definitely use it if you get stuck.